Hello students, welcome to this module number 5, that is other materials and material selection. Okay, so in this chapter we are going to discuss about it is introduction to ceramics and types and characteristics of ceramics and its applications. So let us discuss to know about the ceramics and why it is used and also it is how it is different from the other materials. Okay, so the ceramics are inorganic solid material that is containing compounds of metallic and non-metallic elements, most frequently oxides and nitrates and carbides. Okay, and also this history of ceramics can be traced more than back more than 10,000 years. So this inorganic material that are providing a platform for a modern day revolution in the material technology. Okay, so leading to a new development of opportunities for these manufacturers in a wide range of engineering applications. Okay, this for this structures of ceramics we can see so how the structure is going to be different because the various properties found in ceramics is the result of its structure and strong primary chemical bonds, okay, that holds the atoms together to form a new that is ceramic material. So the two common chemical bonds for the ceramic materials are covalent and ionic bond. Okay, so already you know that the ionic bond occurs between the metallic and non-metallic elements that have a large difference in their electronegativities, and for the ionically bonded structures tends to have rather high melting points since the bonding uh, and non-directional methods. So on this uh, events, of other hand, the covalent bond occurs between non-metallic elements having small electronegativity differences. So many ceramic materials contain both ionic and covalent bonding, but the overall properties of this material depends upon the dominant bonding mechanism. Okay, so with this reference to this structure, the ceramic material may be in a crystalline state and with atoms bonded together in a regular platform or amorphous, what we call a glassy material state. So with these atoms having no regular arrangement, so some ceramic materials are like even though if you take a silicon dioxide, SiO2, what we call, can exist in either state. The properties of ceramics material also depends upon the type of atoms present and they are way the atoms are packed in it together. So this is about the structure. While coming to the types of ceramics, it is classified in many ways, but we have shown some group of ceramics we can say. So first one is the conventional or traditional ceramics, and second one is engineering or advanced ceramics. Okay, and third one is glass and glasses and glass ceramics. So these are all different three types of ceramics. So first we'll discuss about the conventional or traditional ceramics. Okay, so this traditional ceramics are those which are made of from naturally occurring raw materials like minerals like clay, silica, okay, feldspar or dolomite, so calcite, etc. These kind of things they are using. And traditional ceramics includes pottery, dish or tableware, sanitary ware, and roof wall tiles, and structural clay products and refractories. So electrical porcelain also, and other things. So although they are used wide variety range of applications of their use to resist the engineering application. Due to these impurities, the starting material which is usually in the powder form. So while considered for the engineering or advanced material, so these ceramic materials are made from the synthetically produced raw materials like oxides, carbides, nitrites, and many more other materials that can offer superior properties and make them suitable engineering materials or applications. So suppose if you take for the materials possess high purity, having high 99.99%, it can be made available in a small and uniform particle size. So leading to this large surface area and high creativity, reactivity, and above all these processing reproducible characteristics, or that is what we call homogeneous of internationally added impurities like um, dopants, aluminum oxide, zirconium oxide, tungsten carbide, and boron carbide, and silicon carbide, and silicon nitride, and aluminum nitride, etc., are the most important ceramics classified under this category, that is engineering ceramics or advanced ceramics. Welcome to this last one, glass and glass ceramics. So usually the glass ceramics forms another class of ceramics material, and it is designed that the crystallization occurs during the processing stage in order to give a fine grained polycrystalline material. Okay, this is about the glass and glass ceramics. And next we'll come to the properties of ceramics. Okay, so there are different properties are there having the ceramics. So these ceramics are having mechanical properties. Well, go through the mechanical properties. There are different variety of properties are having. Okay, this mechanical property is that tensile and compressive strength means these ceramics have a low tensile strength, and however that's the compressive strength of it's around the 10 times of the tensile strength. Thereby, they're making the structural material under the composite loads. Okay, the example of the bricks and stones blocks are good an example for this kind of property of that ceramics. And for the fracture toughness, okay, so since the ceramics materials tends to porous, and this pore along the with the other microscopic imperfections acts as a stress concentrators, and it decreasing the toughness and reducing its tensile strength of the material. And when it comes to the hardness and brittleness, these ceramics are very hard due to the combined ionic and covalent bonding mechanism. However, due to this strong bonding, the atoms cannot shift easily. So, such ceramics material breaks when too much of force is going to be applied. So, next one is wear resistance. So, it is very extremely hardness of the ceramic materials results in exceptional wear resistance. Okay, thereby making them ideal for making the grinding and cutting tools. And the last one is a modulus of elasticity, or we call it as Young's modulus of ceramics. It is a combined ionic and covalent bonding mechanism impart high modulus of elasticity to this ceramic material. So however the modulus is decreases with increase in temperature. So these are all the mechanical property. And we'll come to the another properties like electrical property. So first one is insulator. So the insulator, already you know that the electrons in most ceramic materials are usually not in a conduction band, and it is hence ceramics are considered as insulators. So it makes them to good choice in heating and lightning. So the powder distribution of and other electrical applications. And well, compared to this one more property, that is electrical conductivity. So that is electrical conductivity of that ceramics are made to conduct electrons, which is increase in temperature, or by doping the material with impurities. So the material so called as semiconductors. Okay, and for this piezoelectric property, so this ceramic metals can be piezoelectric by suitable treatment at a high temperature, or sorry, high voltage, known as polarization. This piezoelectric material possesses a property of transferring the mechanical deformation into a voltage changes, or vice versa. So we can make it reverse. Even for the magnetic property also having excellent the so why because the barium ferrite and nickel zinc ferrite display the maximum magnetic properties, so that it is extremely good for the magnetic ceramics, and oftenly used for the computer and microwave devices. Even if you take for the microwave the things vessels which are used for the microwaves are almost all ceramics because of this reason only. And as superconductivity and superconductivity of these materials at complex ionic oxides and possess the superconductivity properties. So having this near to zero electric resistivity and are called high temperature superconductors. So this is what about the electrical properties. Next, other than this mechanical and electrical properties, even for chemical properties also there is oxidation attack and molten metal attack. So oxidation attack means the materials are completely resistant to the oxidation, and in case of molten metal attack, so this material like magnesium, zirconia, graphite, etc. are going to be resist to certain molten metals, and such they are employed to for making the crucibles and furnace linings. Okay, and thermal properties also there, that is a heat capacity and even low thermal conductivity and uh, uh, low thermal coefficient of expansion. These are all some thermal properties. Okay, next we'll discuss about the advantages and limitations of ceramics. Okay, so advantages means so welcome to the advantages and limitations of ceramics. It is a very hard and wear and chemically resistant and a good thermal insulating property, and makes it to use for high temperature applications. Even for the certain ceramics are transparent to light, the making them useful for optical applications. So while come to the limitations, what happen, there is a greater control over the starting powder is essential in order to obtain the favorable properties, and also processing steps and equipments are costlier, and possess low tensile strength and resisting the persisting of is necessary to make it for the suitable use. And also brittleness is a major limitation of ceramic. They possess low fracture toughness and fail catastrophe of with little or no plastic deformation is going to be taken place. And the application, come to the applications, there are huge varieties. There is application, there are excellent in heat uh, capacities. Okay, so that example for the traditional ceramics are used going to making a pottery, dish, tableware, sanitary ware, roof wall tiles, structural clay products, refractories, electrical porcelain and insulators. Even for the burner tips and polymeters and sorry, for the pyrometers also they are used, because the huge temperature is going to be measured by this temperature meter, and even for the radiant heat and supporters and jars, etc. So these are all of the applications of that ceramics.